So these three equations are all related, but they're based on this one equation right here. If you take the probability of an event, like the probability of getting an even number, and you add it to the probability of its complement, the probability of getting an odd number, what should you get when you add up those two probabilities?
Repeat. I'll tell you.
Because you're on your phone.
Well, nobody else is answering.
If you take the probability of getting an even number, and you add it to the probability of getting an odd number when you're rolling a die,
100.
you should get the whole sample space, right? So if you take the probability of an event and you add to it its complement, you should get the whole sample space. What are these last two equations? What are these two? Where did those come from? Look at it, look at it. Where did those two come from?
I don't know.
It came from the first equation, right?
Yeah. Flipped.
How did we get this equation from this one? What did we do? You just took this and you moved this term to the other side. You subtracted it. So another way, again, probability is pretty intuitive, but I'm trying to challenge you to actually make it, to think about the actual process behind it, actually think about the formulaic way to do it, as well as just the intuition part. Because on occasion you're going to get a problem that's a little too complex for you to intuit. And you will need to be able to come up with an actual formulaic way to think about it. Okay, so the probability of an event is just 1 minus its complement. The probability of the complement is just 1 minus the probability of the event. That makes sense, because they have to add up to be the whole sample space. So let's look at